All right, let's get into a story about a scientific idea that was so revolutionary, it nearly torpedoed a young scientist's career before it even got off the ground. It's this incredible story about persistence, rejection, and, in the end, total vindication.
So, it all starts with a question that, honestly, it sounds pretty simple to us now. But back in the 19th century, it was a massive puzzle. Think about it. Pure water doesn't really conduct electricity. A dry chunk of salt? Nope, nothing. But what happens when you mix them together? Suddenly, a current can flow. How on earth is that possible?
And here's the thing. Researchers at the time weren't totally clueless. They knew there was some kind of link between chemicals and electricity. They could see it happen, but the why and the how, that was a complete black box. They just couldn't figure out the mechanism behind it. And this is where our main character steps onto the stage. A young, brilliant, and, yeah, maybe a little bit stubborn Swedish scientist by the name of Svante Arrhenius. And he was absolutely convinced he had the answer.
Now, I want you to just imagine this for a second. You're a student, and your entire future, your whole career, is riding on your final thesis. Well, in 1883, Arrhenius decided to go all in, proposing this completely wild, out-of-left-field theory to solve that salt and water puzzle. So how did his professors react? Oh, they absolutely hated it. I mean, they thought his idea was just too weird, too radical. His thesis got ripped to shreds, and he barely even passed. Just think about that. A massive setback from the very people who were supposed to be championing new ideas. So with his reputation in shambles in Sweden, what does Arrhenius do? He packs his bags. He heads off to Germany, just hoping, to find someone, a community of scientists who would actually listen to his seemingly bizarre idea without just dismissing it out of hand.
So what was this crazy, career-threatening idea that caused all this drama? Well, he called it electrolytic dissociation, and it all boiled down to a brand new concept in the world of chemistry. His explanation was actually beautifully simple. First, he said you dissolve some rock salt, which is just sodium and chlorine bonded together in water. Okay, nothing controversial there. But then came the bombshell. He proposed that the water actually forces the sodium and chlorine atoms to split apart from each other. And here's the absolute key. When they split, they don't stay neutral. They become electrically charged. Arrhenius even gave these newly charged atoms a name, ions. An ion is really just an atom that's no longer neutral. It has either a positive or a negative charge. In our saltwater example, the sodium becomes a positive ion and the chlorine becomes a negative ion.
And that was the answer to the whole puzzle. It's these free-floating charged ions zipping around in the water that carry the electrical current. That's what allows the salt water to conduct electricity. It wasn't magic, it was chemistry, just a kind nobody had ever imagined before.
But, having an elegant theory doesn't mean you get a parade the next day. For Arrhenius, proving he was right wasn't a quick win. It was a long, slow battle that would end up taking 2 decades. I mean, his path really started at rock bottom with that brutal thesis review in 1883. But for the rest of the 1880s and the 90s, while he was working in Germany, he just kept at it, patiently building his reputation and gathering evidence. And slowly but surely, the world of chemistry started to realize, hey, you know what? This guy might be onto something. And that long road eventually led to the ultimate prize. 20 years. A full 20 years after his idea was dismissed as basically student nonsense, Svante Arrhenius got a call from Stockholm. The year was 1903.
He was being awarded the Nobel Prize in chemistry. And listen to this. The reason they gave it to him was specifically for his electrolytic theory of dissociation, the exact same idea that was so harshly criticized 2 decades earlier. I mean, what an incredible moment of vindication that must have been.
And the story doesn't even stop there. The man who was once forced to leave Sweden came back as a celebrated national hero. And in this perfect, ironic twist, he became the director of the Nobel Institute. He helped write the rules for the Nobel Foundation and even had a big say in who would win the prize after him. The total outsider had become the ultimate insider. So the thing to really take away from all this is that it's not just a dusty history lesson. The theory of ions is fundamental to our world. We're talking about everything from the batteries powering our phones to the way our own nervous systems fire. And it really makes you wonder, doesn't it? What amazing technologies do we rely on today, all because one student long ago refused to take no for an answer and dared to be right?